Hello, here we have an exam question on proof. Prove that the sum of any three consecutive even numbers is a multiple of 6, and this is for 4 marks. Now the key here is to tell the examiner that you know what's going on, and it's how you choose the numbers to represent your even numbers. So let the three consecutive even numbers be and let's get cracking here. Let's make sure that the width. Here we go. Right, let's do the maths. So I'm going to let the three consecutive numbers be. Now, we need to choose carefully here. Because I'm familiar with this question, 2n minus 2 is the first one. 2n is the second one because it's even numbers, so we can make it a multiple of 2. And then 2n plus 2 is our third. So then we can say, if we add them, 2n minus 2 plus 2n plus 2n plus 2 is identical and equal to, 2n plus 2n plus 2n is 6n, and minus 2 plus 2, that's 0, so it's just 6n, which is a multiple of 6. Therefore, a multiple of 6. And that's it for 4 marks. So you can say, whoops, that doesn't look very nice. A multiple, we'll write the word out nicely. It's all real time. A multiple of 6. So therefore we can say the sum of 3 consecutive even numbers is a multiple of 6. And that's it for 4 marks. Okay, how about another question now? The set of numbers S is defined as all positive integers greater than 5 and less than 10. And prove by exhaustion that the square of all values in S differ from a multiple of 5 by 1. Now, the key here, and I'll underline it, is where it says prove by exhaustion. That means we have to use a particular technique in order to attain our answer and be given the 4 marks. So the proof by exhaustion is how we go about getting the answer. So if we use, let's erase our red and go to a black. Let's go to black. If we use, and we need to change again the thickness, use 6, 7, 8 and 9. That will be hopefully exhaustion enough. Use 6, 7, 8 and 9. So what we have is defined as all positive integers greater than 5 and less than 10. The square of all values. So we've got to square our numbers. So 6 squared is equal to 36, and then which is equal to, I would say, a multiple of 5. Isn't that 35 plus 1? And what about 7 squared? 7 squared is equal to 49. Well, isn't that a multiple of 5 will be 50 minus 1. So multiple of 5 will be 50 minus 1. And what about 8 squared? 8 squared is equal to 64, which is equal to, again, a multiple of 5. It will be 65 and minus 1. What about 9 squared? 9 squared will be equal to 81, which is equal to 80 plus 1. And if I scroll down, so I said I use 6, 7, 8, and 9. 35, 60, and 65 and 80 are all multiples of 5. So 35, 50, sorry, 35, I use 35, 50, 50, 65, 65, and 80 are all multiples of 5. Are all multiples of 5. So by exhaustion, the square of all values in S differ from a multiple of 5 by 1. So therefore I can write by exhaustion the square of all values, of all the values that I use, of all values in S differ, and this is in the question, differ from a multiple, differ from a multiple, that's better. I don't want to sound verbally dyslexic, but S differ from a multiple of 5 by 1. And I think that's proof enough for 4 marks. Okay, that's proof part 1.